Unveiling the Universe, a revolutionary perspective on the origin of everything. It is pointless for science to debate what existed at the origin of the Big Bang, because the next question will always be, what was there before the origin of the Big Bang? The answer is another universe. It is not satisfactory, because the next question is, yes, but what was there before the first cycle? Certainly, it could be an infinite cycle, but then we would have to hypothesize a curved, circular time. The important thing in reasoning is to hypothesize how something can arise from nothing. Here lies the first great mistake that has always been made, considering two categories, what is and what is not. With this premise in a cause-effect relationship, it will be impossible to answer the question of how the first object appeared in the universe. If the void at the origin was a quantum void, which by definition is a bubbling of virtual particles and antiparticles, then it would not be the nothingness from which everything necessarily arose. Nothingness must be nothing. But then, nothingness is a non-being of everything. This is what the universe must have been born from, nothingness as the negation of existence. And how can something arise from nothing? Here, logic and mathematics come to our aid. In fact, in the beginning, there was nothing. So at the beginning, there was only zero, absolute nothingness, without time, which is an illusion, and without matter within it. Then, what happened? Nothingness lasted very little, indeed nothing, because nothing is a concept in itself, the absence of everything. So we have zero, nothingness, and immediately we have one, the definition of nothingness, which is already something. The universe now has two elements, 0 and 1. Mathematically, we already have binary numeration. And how was matter born? Referring back to when I spoke of the great mistake of considering the category of being and non-being, the answer is that matter does not exist as a thing. Nothing exists in this sense. Everything is a non-being. We can say that the universe is a mathematical structure. In the end, it is the only thing that makes sense. Another great mistake is considering the existence of time. Time does not exist. What we call time is simply a variation in the position of two entities that makes us believe there is a before and after. It is the difference between a photograph and a film. But if we look at two frames of a film, it is not necessary for time to pass. They can easily coexist simultaneously. It is we who, looking at one frame at a time, have the illusion of the passage of time. In reality, in the mathematical universe, the change between two states is the obvious consequence of state 1 becoming state 2, as in a mathematical formula. 1 plus 1 equals 2. The first term of the formula, 1 plus 1, automatically generates the second term, 2. The mathematical structure we have defined generates infinities. These are infinities that we cannot conceive in physics, but in mathematics, just knowing they exist, we are used to accepting them. For this reason, the universe, what we see with galaxies made of stars and planets, will eventually be proven to have no curvature or whatever shape it has. It will be discovered sooner or later that it is infinite, like the infinite digits of the product of 1 divided by 3 or the expression of pi. In the beginning, we said there is nothing, the zero, and the definition of nothing that becomes out 1. Consequently, we have binary mathematics as a succession of these two entities. Now, we need to find how geometry can arise from mathematics, and thus the concept of space. Geometry is also an illusion, an extension of the idea of the holographic universe. But unlike that concept, here there are no dimensions, and dimensions are an illusion. Since the mathematical universe is a structure that easily accommodates the concept of multiverses, we need to understand in what form these multiverses coexist. Given that the universe is infinite, sooner or later there will be another Earth identical to ours, except that the apple on the table in front of me is not red but green. Therefore, we can think of as many Earth-like planets in the universe as there are solutions to all the wave function collapses of the entire universe. Starting from the premise of a mathematical universe, infinities no longer worry us. On the contrary, they become a convenience. There are other open questions, and one that remains unresolved in such a universe is the problem of probabilities. In this context, there could exist a planet Earth where flipping a coin always results in heads, while all other probabilities behave as they do in our world. This scenario would be bizarre and seemingly impossible. However, if something highly improbable is not impossible, then such a planet should also exist.